Okay, so part of understanding the difference between Lean and Six Sigma begins with understanding Lean. And that Lean has been around literally since the dawn of time. Cavemen were doing Lean, it was all good. So I always like to start back in the 1500s. If you're a history buff, if you like the History Channel, you may have seen a video on this. It's really fun stuff. But the Arsenal of Venice was this ship-making process that this is at the time when Italy was all a bunch of city-states, so there was no centralized government. It was a feudal system. The one with the most toys won. So if you could outgun your opponent, you won. Now, Venice is at this wonderful port location that everybody wanted to conquer because everybody likes money. And it would have made them very, very rich to have all the resources here. So everybody wanted Venice, which meant that Venice had to be really decked out. They had to be armed to the teeth to defend their own land because everybody always wanted to conquer them. And so what they were able to do was they actually created a manufacturing system where they could make a ship in as little as 1 hour. 1 hour. Now, for all of you that are working in industry, I want you to think about what your company accomplishes in an hour. These are fighting vessels. They have no electricity. They have wood. There was some steel, but forming it was like a guy, like a farrier, having to sit there with an anvil and heat it up and beat it out into shapes and everything. A lot of their connections and fasteners were actually like wood dowels because those were a lot faster to make and they were very sturdy. So these are wood vessels that you could load over 100 soldiers onto these vessels, and they could do it in as little as an hour, working just off daylight and their arm strength. That's pretty freaking cool, if you ask me. That's amazing. Now, how did they do it? Well, they did it with all of the tools that we talk about today, and we talk about them as if they're new. Just-in-time manufacturing. They had exactly what they needed, where they needed it, when they needed it, and only that much because they had very little space. What they did was they built the hull and then they floated it through the canal systems. And when it came out the other end, the soldiers got on. That was the last step of the process, was that the soldiers and sailors actually got onto the vessel and walked off and went to war. Modular manufacturing, so creating offline units that could then be carried onto the ship and installed in place. Flexible manufacturing systems, so not that behemoth of a disgusting machine called the Festo over in the AEC, but actual flexible manufacturing where every station could be outfitted differently. So if they needed to move people around, if they needed more people in one area than another, they could just move people around. Everybody was multi-skilled, and so they could work on any part of the vessel at any time. They did standardized parts out the wazoo way before Ford made it cool. They made sure that everything was the exact same over and over and over so they could make things very quickly. They could pre-cut, prefab, pre-assemble as needed. There was very tight inventory control over all their parts to make sure that they never had to stop production because literally they were floating a boat down a canal. To stop production, they would have actually had to like stop the boat, like tether it, anchor it, something to be able to do that. They were long before the moving assembly line, hundreds of years before the moving assembly line, they were treating it like a moving assembly line where they were getting on and off the ship and doing work as the vessel floated through the canals. It was awesome. It was amazing. This is not new. Now, fast forward to the Industrial Revolution, 1800s, 1900s, we start seeing interchangeable parts in things like clocks, sewing machines, bicycles, woodworking equipment, farm equipment. And then finally, our granddaddy, Ford Motor Company, comes along, integrates all of these things into a moving production line and shows the vast reduction in cost and expediency by doing so, right? So these things that we're talking about that people are like, oh, lean, that newfangled. No, it's ancient. Ever since we've been building stuff as a human civilization, we've been using this. Now, there's a couple key individuals that you do not need to know the names of, but I'm going to go through them real quick. Frederick Taylor. I'll be telling you, so I'm going down this new research path. I'm very excited about it. The first 2 chapters of this book I read over winter break demonized Frederick Taylor like he was Satan himself, and that like really hurt because I identify as an industrial engineer. Like some people have like a gender identity or a sexual identity that is core to their being. I have always felt like an industrial engineer. It's just my view for the world. It's just how I see things. It makes sense to me. Drives my husband nuts, by the way, but it's just how I see the world. And then this very respected author took 2 chapters to dismantle this individual and make them look like all the ills of the world rest on his shoulders. It was a rough day or two, but I sat and soaked in it and was able to kind of think about how that might work. But what he did was he showed value in having standardization of operations, being able to conduct time studies, being able to come up with that one right way. Frank Gilbreth put that into practice and saw how that was used in industry as well. But Frederick Taylor was the one who really made the business case for it. So he had the engineering mindset and the business mindset together that kind of painted this picture. Henry Grant, our famous Gantt chart, you guys all use them in 417 in the project class. He came along and helped added that, but he also was one of the people that first started using visual management tools in the workplace to use sketches and diagrams to help people understand how to perform their task, what they needed to do with their position and how things would go together. So if you've ever worked in fast food and had like a McDonald's circle to tell you where to put the lower bun, Ant was the one who was doing that first, and it's used in all different types. I know Ameriqual uses job sheets like on some of their larger packaging lines where it's a visual depiction of how things were supposed to be set up, that sort of thing. Again, this is happening back in the late industrial revolution, so late 1800s, early 1900s, turn of the century stuff. Frank Gilbreth, I already mentioned, we'll be value stream mapping a lot in this course. He's the one who actually kind of put those tools together first. And the single minute exchange of dies was really coming from his origin. So a key lean item that you hear about all the time in automotive, especially, single minute exchange of dies was really a Frank Gilbreth invention. A.K. Erland worked with queuing theory, which helps us level out production, helps us balance production lines. So that was kind of a fundamental thing. Seward gave us the PDCA or PDSA, depending on which one you want to look at, Plan, Do, Study Act or Plan, Do, Check Act. And also kind of started embedding this idea of Kaizen. He didn't call it Kaizen because Toyota hadn't come over yet, but Seward was one of the people that went over to Japan and actually saw some of these Kaizen, small, quick change being implemented really successfully. And then Ford came along and pulled together all of these different things into a singular workspace and started seeing this overlap between what we see in Japanese manufacturing and what we see in American manufacturing and bridging that gap. So Ford obviously came before that, pre-World War II. We don't get any of the Japanese influence to post-World War II, but pre-World War II, Ford was doing these things, and then it's continually refined and developed even further. So long before the big three really embraced lean, Ford was already integrating this because of his initiatives. Now, he took it way too far where he seriously had a single piece of equipment for one thing only, and if there was a design change and they no longer needed that thing, they literally threw the press away or threw the piece of equipment away or threw the tooling away. It was that specific. It didn't have any flexibility to the system. That was something that got added later. But really, really embraced it in a way that made sense for manufacturing. So when we think of lean, and if you think of like McDonald's class, and maybe some work that you've done with Lara Gracia as well, you've got to be thinking Toyota production system and saying, Susan, when are you going to start talking about Toyota? Well, we're going to talk about it and we're going to move on from it because we really don't care very much about him. Other than the fact, Dr. Davis doing? Yes, I know it's Dr. Davis. I don't know what he's like farm animal he's mimicking. Maybe Kirby can tell us. Is that the cow and heat? Is that what we're listening to?
Something was in distress.
So post World War II, can anybody tell me what had happened in immediately prior to 1950 that would have maybe influenced Japan's need to become efficient? What happened in World War II to Japan?
They got blown up.
We blew them up a lot. So they had to rebuild. They had very few labor. They had very few resources. They had no money, which meant lean was a necessity to them. And that is why, even though we have all of these American engineers who created these concepts, Toyota was the first one who combined them in a system that actually embedded continuous improvement and process improvement throughout the entire system because they had to. They had to. There was no other choice. They didn't have a lot of people, so every person needed to be able to do everything right the first time, and they had to be able to move from one production area to another seamlessly. They didn't have a lot of raw materials, so you couldn't have waste. You couldn't have defects because they couldn't afford the scrap. They couldn't afford it. So these principles that we come in and like knights in shining armor, like, oh, I could make your factory better. Like, this was the only way it was going to work. This was the only way they were going to rebuild their country. And so they had a motivation that was heightened because of their socioeconomic status that allowed these things to move forward. And because of how the government works in some of these other countries, including Japan, that the emperor can actually say, like, we're going to do this and everybody's going to do it. And it's not a matter of like corporate individuality where a business says like we're going to do things a certain way. Their government, actually, their imperial government actually funded the plants and wanted accounting for everything being exactly the right way. And so to make that possible, they produced what we now call the Toyota production system. We're going to end there because I'm supposed to be done now. Please do not forget to do that survey.